Well, hello, BC Calculus students. Looks like it's time for the second half of the 2016 free response scoring. So remember, this is to be watched after you've finished this, and this will give us an idea of how these should be scored. So let's go ahead, let's take a look here. So this is question number 4, and this one has some BC elements and some AB elements in it. There's usually one question that's a mix. This one is the mix question. So the first thing we have to do, we see in part A, they want us to find the second derivative of this differential equation. This differential equation is the first derivative. So once again here, we have to go ahead and implicitly differentiate that. So here is what you see. This is worth 2 points. And basically, you have to get the second derivative, which is this expression right here. It's pretty much a package 2 points. If you do this and you forget your dy dx, and you just say it's 2x minus 1/2, I think that gets you nothing. But if you put your dy dx here, but then you don't substitute in, that gets you 1 of 2, if you did that. So that's kind of what you've got there. All right, then for part B, you see we've got, this is the one where, no, never mind. I was going to say it was something different. So we've got this, supposed that we got y as the particular solution. We don't know what the function f of x is. We just have to know that it exists. But we do know it goes through the point -2, 8. So now we have to know, does the graph have a relative minimum, relative maximum, or neither at the point -2, 8? So at this point here, what we would have to do is, first off, for it to have a relative min or relative max, the derivative would have to be 0. So the first thing that we would do here is we check the derivative, which we do have. We don't have f of x, but we do have the derivative. We check the derivative and find out that it is 0. So you have to check your first derivative. So it is a critical point. But then to know whether it's a minimum, maximum, or we have to do the second derivative, plug in the values for our second derivative and find out that it is, in this case, negative. Therefore, our function is concave down. So that does make it a relative maximum. And the reasoning is because the second derivative is negative. So it's 2 points. 1 point is essentially for getting the conclusion. If they can't get the points for saying it's a relative maximum without having the correct first derivative and the correct second derivative. But if they do have the correct first derivative and second derivative and then make a mistake here with the interpretation, they would get 1 of 2, or you'd get 1 of 2. Okay, for part C, now we're definitely at the BC part. So we've got this information here, and we need to find this limit. So what we find out is when we plug in the value of -1, we know we're told that g of -1 is 2, so that makes the numerator 0. And if we plug in -1 into the denominator, we see it is also 0. So you have to first do something where you say it is the form 0 over 0. Notice here they said the limit, so the numerator is equal to 0, the denominator is equal to 0. You cannot say equal to 0 over 0. That will cost you a point. You have to say using L'Hopital's rule. You have to say that somewhere. And then when you actually do L'Hopital's, we need to see it used correctly. So there's 2 points here. 1 point for showing an indeterminate form, and saying use L'Hopital's, 1 point for correctly doing L'Hopital's, which is take the derivative of the numerator, which is g prime of x, and the derivative of that given denominator. And so now we can go here. We know that g prime at -1, we are given that value there. So we know that g prime at -1, we know that from since g is a particular solution, we know that it's going to be this function here. So when we put in our value of -1, and since it goes through -1, 2, we know we get 1 minus 1 there. So we can evaluate that. and we get that's 0, and we get that the denominator is 0, so we have to use L'Hopital's rule a second time. And when we do this, we get our second derivative, which we know we can find, and we plug in the point there to get -2. The denominator is 6, so we get -1/3 for an answer. All right, then for part D, you have to use Euler's method. So basically you get a 1 point if they can demonstrate that you understood Euler's method and the process is there. So it's 1 point for demonstrating the process, that you start with a value at 0, you take the derivative at that value, multiply by 1/2, get the new value there, which is a value plus that, which is 3/2, then go ahead and use that 3/2 when you go to do your next value there, and go through the process and get 5/4. So if you have the process, you get 1 point. If the process leads to the correct answer of 5/4, you get the second point. Okay, question 5. This is an AB question. So here we've got our funnel with circular cross sections. So the first thing says find the average value of the radius. So the average value of the radius is a given function here. So basically we're just finding the average value of a function. So we know it's the integral divided by the interval. The interval is 10. The height goes from 0 to 10. We take the integral there, evaluate. If you get the correct integral, which is 0 to 10 of 1/20 3 plus h squared dh, that gets you 1 point. If you take the correct antiderivative, which is what is inside of these brackets here, you could have factored the 1/20 out, that's okay. So you get what's inside the brackets there, you would get the second point, and then if you have your correct constant there, so you end up with a correct answer of 109/60, you get the third point. For part B, find the volume. Since it is circles, the area of a circle is a cross section. So here's our radius function. So we have pi r squared. If you have the correct integrand, that's the thing that you're integrating. So that would be 1/20 3 plus h squared squared. The pi can be inside or outside. But if you have this thing squared, even if you don't have the right limits, you get a point. You get a second point if you anti-differentiate this correctly, and you actually get the pi over 400 times this 9 plus 6h squared plus h to the 4th. And then finally, if you evaluate correctly with 0 and 10 and get to your correct answer of 2209 pi over 40, that gets you the full point. And you could have left it like this. This does not get you the point for the answer. You actually have to do evaluate, but this does. So you could have simplified, or you could have just left it just like that. Full credit for leaving it like that. Then for C is worth 3 points. So we need to see the chain rule in action here, which means that when you take this derivative here, you'll get 1/20 2h. You need to have this dh dt. We need to see that in action. And then we can substitute in and get your answer of -2/3 inch per second, although you don't have to have units. You'll be okay there. So 1 point if they get the 1/20 times 2h, the dh dt, making that there gets them the second point, and then evaluating correctly gets the -2/3. All right, last question. Question 6. This one's all BC. We got our good old series question here. So first, we need our first two terms. So we have to write the first 4 non-zero terms. So here's our value at f, our first derivative at 1, second derivative at 1, third derivative at 1, getting our first two terms. So here's our 4 terms right here, 1, 2, 3, 4. Our first 2 gets you 1 point, 1 minus 1/2 times x minus 1. Getting the third term correct, so you can write it out like this, or you can simply write it as 1/8 x minus 1 squared. That gets you a second point. Getting the fourth term, which can be written like this, you can leave it like that, or you could actually go ahead and write it as You got to have the minus 1 over 24 x minus 1 cubed. That would get you the third point for the fourth term. And then the expression here for the general term, that gets you the fourth point. Part B. Part B, you get 1 point if you identify both endpoints. Got to have -1 and 3. Just one endpoint doesn't do it. You got to have both of them. And then the correct analysis here gets you the other. So this one here, when x is -1, this series is going to diverge, and you can say, they say it's the harmonic series. You can also say it diverges by the p-series test would be the easiest way to say it. That would also work. Either way would work on that. And then in this case, when x is 3, now it's alternating, so it converges by alternating series test. So therefore, your interval needs to have -1 open, x to 3 closed. So the first point's pretty easy. The second point takes a lot more work. For part C, you just get 1 point. If you get your correct approximation, you plug in and you get 0.905. Part D, worth 2 points. If you have the correct form of your error bound, which in this case, because it's alternate, you could do the alternating series error bound. So that's simply just knowing that the error bound here is the next term. So it would be the third order term, the third power. And then if you do the correct analysis that error, that's an expression for error, has to be less than the bound, which is less than, which that bound equals 1 over 3,000, which is less than the actual error that we know we have. So we see that that we do have that, or sorry, it's less than the value given. So it is, we can say that our error is less than that. Okay, that's what you've got. Score each one out of 9, score the whole thing out of 27, and go ahead, take a picture of your work and make sure you get it posted. All right, hope you're doing well. And if you have questions, remember we do have another Zoom session on Friday. Or you could always, if it's a quick question, you can always just send it to me by email or Google Classroom. All right, bye.